Let's transition from that to exactly some of these kinds of challenges, namely two, before we wrap up. So in the world of SQL, especially when it's used at scale, at the Twitters and the Googles of the world, like lots of data is probably coming into the database all at once because multiple people are opening their phones at the same time around the world. They're clicking on the same links roughly at the same time around the world. When you have thousands of people all using your site at once, like order of operations is going to be important. But unfortunately, in SQL and in other contexts of computing, there's this risk of what's known as a race condition. So for instance, has anyone ever seen or liked this? This is like, yes, the world record egg. Or it's like this thing that was very popular a while back. It's still kind of going strong. But if you go to the Instagram profile for world record egg, the goal was to make the most liked Instagram post ever. And they did pretty well. It's just this. It's just a picture of an egg. Now, at the height of the popularity, like there might have been hundreds, thousands, tens of thousands of people clicking pretty much at the same time on this egg. So it actually creates a potential problem with the integrity of Instagram's data. Why? Well, if you have all these requests coming in at once, how do you possibly keep track of all of them and update your counter in a way that can keep up with all of that traffic? Why? Well, let's just hypothesize what Meta, formerly Facebook, was doing underneath the hood with Instagram if this were their code. So suppose, for the sake of discussion, that Instagram servers are using a mix of Python and SQL. Probably not using the CS50 library, but they could absolutely be using those two languages or two others together. Suppose they do this in order to update the number of likes for that post. They first execute a SQL query like select the current number of likes from a table called posts, where the ID of the post equals whatever the unique identifier is for that specific egg in the table. And then they store the result in this rows variable, just like I did. And then they do this. They create a variable called likes. They set it equal to rows bracket 0, so the very first row in the result set. And they get the likes key. So this is literally what I just did with the count. Let me hypothesize that Instagram does something similar with the total number of likes. Why are they doing this? Because they then want to execute a third line of code that executes update the posts table, set the new number of likes equal to something where the ID of the post equals this other thing. Now notice, just like in printf, there's the comma-separated list of values. They want to update the current number of likes from the current value to the current value plus 1. So it's likes plus 1. And then we plug in the ID for this. So suppose this is what Instagram's doing. Unfortunately, whenever you execute multiple lines of code independently, and you're so popular like Instagram that you have thousands, hundreds of thousands of servers potentially, it is quite possible that if you and I and everyone else in the room clicks that egg at the same time, it's not going to be the case statistically that like 3 lines of code are executed for me, and then 3 lines for you, and then 3 lines for you. They're probably going to get interspersed. Like this gets executed for me, and then this gets executed for you, and then they get back to doing work for me, and so forth, just to kind of multitask, just like a human might, but at a super speed here. The problem, though, is if these lines of code get interrupted, what could go wrong? Well, suppose that Carter and I both click the egg at the same time, and suppose the current number of likes back in the day is 100. That stores in this variable the value 100. But if we click so close in time, we might get back the same answer to this select query. As of that moment in time, when David and Carter clicked, it had 100 likes. But then this last line of code is executed for me and then maybe Carter. Because that answer, the state of the database, was stored in this variable, then both Carter and I will result in this line of code being executed with the same value. Update the posts table, setting the likes equal to 101 for that post's ID. Why? Because again, if each of these lines of code running on different servers are checking the value of the current number of likes, but then getting interrupted because Carter clicked the darn thing too, and then resuming their work on my behalf, we might have a race condition where the code is sort of racing to finish, but getting interrupted by other users' clicks. And the problem with that is that if you are inspecting the value of some variable, or in this case, a database cell, and making a decision based on it, like how to update it, you might now lose data. And Instagram, probably not good for advertising if they're losing likes. And so that's probably a problem, not to retain the value 102 and instead insert the number 101 twice. It's actually similar in spirit to a story that was told in a databases course I took myself years ago, whereby It's somewhat analogous to kind of a contrived scenario involving like a refrigerator. And this is the closest thing to a refrigerator we could get on stage. But imagine you've got like one of these little dorm fridges in your dorm too, and your roommate. And maybe both of you, as the story was told to me, really like milk. And one of you's at class, but the other of you comes home, and you open your dorm fridge, and you're like, oh, darn it, we're out of milk. And so you close the fridge, you walk across the street to CVS or some other store, and you get in line to buy some milk. Meanwhile, your roommate gets out of class, they come back to your dorm room, they're really thirsty for some milk, they open up the fridge, they say, oh, we're out of milk, and then they take a different route perhaps to CVS or some other store nearby, get in line to buy some milk. Fast forward some amount of time in this very contrived story, and what happens, oh, damn it, we now ended up with like 2 gallons of milk, and there's no way we can fit gallons of milk in there, let alone 2 of them, so that's a problem. But what's the relationship to this here? Well, both of us, yeah, did what? Exactly. Exactly. So to summarize, both of us had a very similar thought process, made a similar decision based on the same information, not realizing that the information, the fridge, was in the process of being updated. And it, of course, in the Instagram world happens like this. In the fridge world, it might take a few minutes, but the problem is ultimately the result of our having made a decision about the state of the world, and the state of the world was in the middle of being updated. The queries got commingled with others, or in this case, someone was already on their way to the store. So what's the solution in the real world? Well, you could, very simply like take a Post-it note and put like gone for milk so as to communicate to your roommate that they should not inspect the value of that variable and make a decision on it. Why? Because it's not yet consistent with the outcome that's about to happen. You could be more dramatic and you could actually lock the fridge somehow, put a padlock around it or the like, so they can't even get in there, and that would achieve the result, the same effect too. And that is actually pretty much the solution to this problem in code too. It's not safe, it's not sufficient to only execute 3 lines of code like this. Rather, what you probably want to do is use additional SQL keywords that we won't spend much time on in the class itself, but these. There are solutions to this problem. You can begin what's called a transaction, and you can more explicitly commit to making a decision, like updating the database to 101 or 102. Or if you realize, wait a minute, Carter's query is interrupting mine, let me roll back to the previous state and just rewind. Let me undo, Control Z, if you will. There's also another keyword that's not so much used anymore in SQL, which is locking. You could literally, back in the day, lock the entire database table, preventing anyone from updating it or making changes or even reading it while someone else was accessing it. That was a very heavy-handed solution because it slowed everything down. But in short, transactions are now a feature of SQL that you won't necessarily need to use yourselves that do solve this problem by doing the equivalent of saying, while David's like counter is in the process of being updated, keep Carter at bay, ideally briefly, and then let his data go through too. It's equivalent to putting a note or a lock on the fridge. And indeed, I mean lock literally. They were once upon a time called, and still are in some texts, called locks on databases too. And the last and the code for which you might do this is almost the same. You simply wrap the 3 queries with a transaction statement and a commit. And the term of art here is that this makes your statements atomic. So atomic means they're either all executed or not at all. That is, they're all very tightly coupled together without interruption. Transactions solves that problem and avoid having 2 gallons of milk. And the last problem that arises that is tragically so darn common in the real world today is what's called a SQL injection attack. And it's what I alluded to earlier with the question marks. So suppose you're in the habit of logging in to Yale websites with your NetID or password, or at Harvard, your Harvard key and password as well. Suppose for the sake of discussion that the people that implemented like Harvard key login allow you to type in your email address, of course, and your password. But suppose that they are using SQL underneath the hood to check your username and password to make sure that you are David Malin or Carter Zinke or whoever you claim to be. I haven't shown you the syntax yet, but it turns out that in SQL, Dash dash is a special way of indicating a comment. It means ignore everything to the right. So it's just like slash slash in C or the hash symbol in Python. Dash dash just means ignore everything to the right. And we've, of course, seen single quotes. So one way to wage a SQL injection attack is to try to inject malicious SQL code into someone else's database without them realizing it. How do you do this? Well, suppose I log in as mailin@harvard.edu, single quote, dash dash. I'm not double quoting anything clearly, and there's nothing to the right of the dash dash anyway. But this imbalance is going to be useful. Why? Because if I'm a hacker and I'm presuming, someone at Harvard probably is using single quotes to wrap the user's email address and wrap the user's password, what if I try to complete their thought for them and close one of those quotes for them? What might happen? Well, we could do this. Here, for instance, let me hypothesize, is the code that Harvard wrote, hopefully not, underneath the hood. So they're using CS50's library in Python, and they're using SQL inside. Suppose that they have a query like this. Select star from users where username equals question mark and password equals question mark. And then suppose they just plug in whatever username and password was typed in. And then if they get back some number of rows, dot, 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 they assume I am David. They assume Carter is Carter if both the username and password are in the database. Just end of story there. This is good. This has the question mark placeholders we discussed earlier. But what if you don't quite remember that? You don't quite take that to heart, and you use your more familiar last week F strings, whereby we use these curly braces to plug in values. What if you do this instead? So it's almost the same idea. It's still db execute, but now it's select star from users where username equals. And now notice I'm doing the single quotes, which is required by SQL, but I'm using F strings with the curly braces. And the password equals single quote, password, and then close single quote. The problem is if you're just blindly pasting effectively the user's input into that web form into the username field and the password field, there's nothing stopping a malicious user, student, faculty, staff from including a single quote in their name. Or maybe even, benevolently, if their name happens to have a single quote, as some last names in particular do. So this is very fragile. Why? Well, suppose that if we plug in my malicious value, mailin@harvard.edu, single quote, dash, dash, notice what happens to username here. The username variable inside of the curly quotes will get replaced with this. And notice, single quote, which the Harvard programmer wrote, malan@harvard.edu, single quote, which I wrote, dash dash, which I wrote, single quote, which Harvard wrote, and whatever else they want after that. What's the implication, though, of the dash dash? Everything to the right is going to be ignored. So the password is never even checked in this scenario. I'm tricking the server into ignoring everything after the dash dash. But I have constructed very cleverly, very maliciously, a syntactically valid query. Why? Because I provided the single quote that's going to finish the thought of that first single quote. And now, I would only know how to do this if I saw the code or if I just randomly try putting apostrophes into web forms and see if things break. That's often how adversaries attack systems. They type in potentially dangerous characters, hit enter. If something breaks, they're not necessarily into the system, but they know that there might be a vulnerability. And then they start trying more methodically things like this. So this then is going to be bad because it effectively grays out the rest of the query. And this query is surely going to return some rows without even knowing my password. And so this logic here, dot, 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 means, well, if data came back from this query, Harvard is presumably going to assume that Malin logged in, show him his account, or whatever is being protected here. So in short, using F strings, bad. Using any equivalent like %s in C, bad when it comes to SQL. Using question marks or whatever a third-party library like CS50's prescribes is the way to solve this. Why? Because libraries like ours are designed to at least be smart and be paranoid. And what we will do is this. When you use the question marks and the value is plugged in, when you use the question marks and the values are plugged in, we will escape any potentially dangerous characters inside of those placeholders. And so effectively, the single quote will no longer be considered a grammatical single quote. It will just be literally a character in the username or password. So the library takes care of this for you because you're plugging in the username and password as separate arguments. And then we, or the third party you're using, actually sanitize, that is, clean up the data and prevent those bad characters. Now, this is kind of an internet meme that went around for a while. If you've ever driven a car, been in a car where there's like the automatic readers for tolls, this person thought it might be funny to try doing something like this. What are they presumably doing? The presumption here is, whether or not it worked is unclear, is that here's like the end of an actual license plate number, but here's an interesting single quote and a semicolon. That's especially bad because it means you can maybe execute a second query on the database. This is someone having fun trying to drop the entire database table for whatever municipality is scanning through cameras their license plate code. And I would be remiss if we didn't end on this note. At least in computer science circles, there is someone named, no relation to the TF name we put in the database earlier, Little Bobby Tables, which ends with this XKCD comic. And if you chuckle, if you laugh, you're now legit SQL programmers. Nice. Nice. Like every CS student out there knows about Little Bobby Tables. So if you name drop Little Bobby Tables now, like you're in. All right, that's it though for today. We will see you next time.